We're going to look at the attributes of functions today, and we're going to begin with the equation f of x, or remember this is like saying y, equals 2x minus 3, and we're going to investigate what's happening between the interval of -6 to 2. Now, hopefully over time you'll be able to understand a little bit better without maybe sketching it out, but as you need to, sketch the function, see what's happening with it. Okay, so we're going to start by, if you need to, because not every person will need to, graphing it. One thing that we want to notice is that this is to a first degree. Remember, there's a little 1 up here, which means this is a line. And lines go straight in one direction or the other forever, both ways. So, 1, 2, 3, my y-intercept is -3, and I'm going to go up to 1, 2, right 1. I'm going to do that a few times to plot my points. Remember from geometry, 2 points makes a line, but I like to plot at least 3 so I can get a pretty good looking line. Okay, so there's my line. So the first thing that I usually am going to answer about this is I'm going to answer domain and range. Okay, when I'm looking at domain, if I imagine this going off forever in all directions, you'll see that I'm using all of my x's out here, and I'll just keep plotting points using all those x's. That means that my domain on a problem like this is going to start at -infinity. And as I'm going up to the right forever, I'm going to keep using all of those x's. Okay, so I'm going to go +infinity. My range, I'm going to be at the bottom, and I'm going to keep using all my y's, -infinity, and I'm going to go up to +infinity. Okay, so we work from left to right and down to up. The next thing I'm going to ask is, well, what are your x-intercepts and y-intercepts? Now, this is one where you may be thinking to yourself, well, you know, this is pretty straightforward. My x-intercept is in here somewhere. I'm actually going to not be perfect. My y-intercept is really easy. That's 0, -3. But what if I didn't graph this? So let's go back to Algebra 1 when we talked about finding them by hand. Remember, an x-intercept is some value with a 0 for the y. And a y-intercept is going to be a 0 value for the x and a blank for my y. So what that means is I'm going to take that 0 and I'm going to plug him into my equation. Because remember, this is really y equals 2x minus 3. So that means that 0 equals 2x minus 3. Solving for x, 3 equals 2x. And x equals 3/2. So this is going to be 3/2, comma x. Well, you may have been like, well, I could have figured that out by looking. We are going to have points that are thirds and maybe a seventh here and there. You need to be verifying what that value is, and you do that by plugging that in. Now, the y-intercept means that we know for sure the x value is 0. So this is where we say evaluate the function when x is 0. That's what that means. Every time you see x, put 0 in. So this is going to be 2 times 0 minus 3. This is my y equals 0 minus 3. So my y equals -3. That means that my y-intercept is going to be 0, -3, which we just proved right here. The next thing we're going to do is find the maximum and minimum value of the problem using those numbers. So you're thinking to yourself, okay, well, the maximum is going on forever and ever and ever and ever, but we're not actually looking at that. We are looking specifically from the -6 to the 2. So what does that really mean? Well, we're going to take, I'm going to always start with that number on the left, okay, and I'm actually going to highlight 1, 2, 3, 4, 5, 6. So I'm going to be somewhere down here. So let me go let's see, 2, 1, I'm kind of off here. 1, 2, 1, 2, 1, 2. So I'm probably down here somewhere. And I'm going to finish at a positive 2, 1, 2. Okay? So I'm looking at this portion of my picture. Remember, I'm still continuing on forever. I just got tired of drawing it. Okay? So the next thing we're going to do is we're going to find the maximum and the minimum. Now, in this case, I'm not going to tell you, like I kind of wrote here, the domain is this, the range is this, and so on. I don't always know what's going to work out as. It kind of depends on what the function looks like and what that value is. So I'm going to say I'm going to evaluate my function when x is negative 6 at 2x minus 3. So 2 times negative 6 minus 3, negative 12 minus 3, and that's going to give me negative 15. So I have negative 6, negative 15 as a point. Okay. Then I'm going to come to the minimum, and I'm going to come up here, and I'm going to check it at 2. So I have the function evaluated at 2 equals 2x minus 3, 2 times the 2, right here, minus 3. 4 minus 3 is 1. So now my point is going to be 2, 1. So the question is, which point is higher? Well, if I go to 2, 1, is that higher than a negative 6, negative 15? Yes. So in this case, this is the maximum point. This is going to be my minimum point. Alright? Now, do I really have to have a picture for this? No, I didn't. I could have easily just solved plugging in my numbers. So it depends on what portion you're in. In the beginning, you may want to have those, but as time goes on, you'll probably be able to remove the picture and save a little bit of time. Remember, we want to pay attention to what degree our function is in. Lines are going to extend forever in both directions. If this is a 2, we have a quadratic, which is a parabola. And if it's a cubic function, we're going to want to investigate that even differently. If you're not sure what it looks like, make a chart and check it out. See what's happening so you can understand that better. Okay? Don't just kind of guess off what happens. All right. Best of luck to you.